Today we're going to be compiling the OpenCV project from its source code and also learning how to use the binaries as a result of the compilation of the source code. So essentially it deals with not only setting up the environment to do such a task and not only compiling the source code into a set of binaries, but actually how to use those binaries and include them into a project of your own choice. The first natural question is, why would you even want to compile the OpenCV project from source? Why not just download the binaries themselves and include it directly in your project? So there are basically four main reasons why you would want to compile from source, because essentially it's a little bit of a trickier and longer process. But the benefits you get are the following. You can utilize the extra modules that the OpenCV project offers. And if we just go through each of these benefits one by one. So what does utilizing extra modules mean? So if you take a look at the OpenCV project, it's essentially compiled of main modules, which give you the stable APIs of the project. These are essentially modules that have been thoroughly tested. They pass all the strenuous tests that the project has in place. The APIs are stable, and essentially the support provided for each of those should a user require support for any of them. And these are the main modules that the project currently has. 4.6.0 as of the making of this video. And essentially, if you download the binaries, you only get the capability of the main modules. Now, OpenCV is a bit more powerful in that there's functionality over and above the main modules. So you get extra modules as well. Not going to go through them in detail in this video, but as you can see, there's quite a bit here. In fact, a lot more modules than the main modules. So these are considered not as stable, or let's say not stable. The strenuous tests aren't in place. If there's support required for those, you're pretty much on your own. So these are not included in the binaries. So if you compile from source, you get to use all this additional functionality. So that's basically the first main benefit that you get. The second benefit is you can obviously tailor OpenCV to your needs. Remember, when you download a binary, clearly you don't have the source code to edit to your needs. So you can't optimize the algorithms. You can't add additional functionality. You can't build off what has already been made for you in the OpenCV project. So if you want to use OpenCV as a base, the source code, and you want to enhance it or change one of the algorithms, or optimize it, change functionality, etc., your only option really would be to compile from source. The other reason is also to contribute to the OpenCV project, which is pretty much tied in with the other reason. So if you go to the OpenCV GitHub repository, essentially, as of the making of this video, there's 374 contributors. So, if you want to basically get your hands dirty and, contribute and improve on the capability of OpenCV, you're going to pretty much have to work with the source code and actually code. And to do that, you're going to need a lot more than just the binaries. You'll need the source code. And then fourth is obviously just to gain a better understanding of computer vision and OpenCV in general. Yes, you can become a computer vision expert just by using the tool, but you can be a lot more than that by being a thought leader in the actual tool, in the development of the tool, and understanding the inner workings of the tool. That'll basically enhance your skill set, which you won't be able to do if you just have the binaries. So in this specific tutorial, we will specifically be compiling from not only the source code of the OpenCV project, but we'll be compiling from source the extra modules as well. So when we say we're compiling from source, we're going to be doing the main modules and the extra modules. You can compile from source just the main modules, but it's pretty much the same process. might as well just kill two birds with one stone and just do everything, the largest subset of the two. But again, the process is pretty much identical for both of them. Now, there are many ways to compile from source. Different environments, different tool chains, compilers, linkers, etc., operating systems. In this tutorial, we'll use one of the most common of those combinations. So the operating system we'll be using is Windows, and the IDE, or the Integrated Development Environment, we'll be using Visual Studio. We're going to be setting up the environment to compile the OpenCV source code into binaries, and also to use that environment to utilize the generated binaries into our own projects. So setting up an environment is important for two reasons: to compile the source code into binaries, and then to make your own projects that utilize those OpenCV binaries as a library. So setting up an environment essentially means installing an operating system, installing an integrated development environment, and letting that integrated development environment use a specific C++ toolchain. So we will assume that you've already installed the Windows operating system with the system type being x64, so the 64-bit version, Windows 10. Next, installing an appropriate integrated development environment. In our case, one of the most common, robust IDEs is Visual Studio. So as of time of recording of this video, they're on the 2022 edition. And there is a community edition available, which means there is no required paid subscription on a monthly basis to use the tool. And Microsoft has in fact gone a very long way to make a substantial set of their software products community editions, which is great. So to install the Visual Studio, essentially, if you go to their website, so visualstudio.microsoft.com, here's the Community 2022 edition. I've already got it installed on my machine. So if you go ahead and click that, you'll download the installer. The installer will fetch the required files. So download them and then go through the installation process. As part of the installation process, so immediately thereafter, you'll be presented with an option with what tools you want linked to the IDE. So tools are essentially those back-end things that make your software projects work. Now, in my specific case, I deal with a lot of web development. So I've got ASP.NET and web development enabled, and I use Visual Studio, the Community Edition, to work on that. I've also previously worked in .NET desktop development, so I've included that. If you don't work in those, obviously you can uncheck them, but for the purposes of only downloading and compiling from source the OpenCV project, the only one you really want here is desktop development with C++. So you want to go ahead and select this one, and you don't have to select anything else. I've just shown you this whole suite of tool chains just so you can understand what it's about and why it offers you these different options. As you can see, Visual Studio is not confined to one specific tool chain, which is obviously great for the community at large. Now, when you select, so once you download it, there might be default options. So let's say all of these will be unselected. So you'll go ahead and select this one here, Desktop Development with C++. What does that essentially do? What do we mean by tool chains or tool sets? So there we're talking about compilers, linkers, build tools, and other auxiliary, backend software products. But if I can go through them one by one, the most important ones, the critical ones, is first and foremost the compiler. The compiler, remember what the compiler does. It, as an input, it takes the C++ code, in this case a C++ compiler, and it generates a set of machine code. Whether that machine code is objects, executables, libraries, dynamic libraries, they're all binaries. They're all machine readable code, which are then interpreted by the target platform. The target platform is the platform that understands and can read and interpret those binaries. So in our case, the tool chain that Visual Studio comes default with, should you select this option, is the Microsoft Visual Compiler. I've never been a fan of visual in the word Microsoft Visual Compiler. There's nothing visual about it. Compilers don't have a visual element. They take in source code of a language and then turn it into machine code. But in either case, this installs a compiler by selecting this, which is the Microsoft Visual Compiler. That gives you the version. And that compiler's target platform is x64 / x86. So that's going to be selected by default. In fact, all of this is going to be selected by default. You don't have to change anything. This is more of an explanation. The other important thing here that it installs as well, if you just go down here, the C++ CMake tools for Windows. So this will be covered in the next tutorial. That essentially tells you what build instructions do you need to build the project. So you'll see later when we download the source code from OpenCV, it comes with a CMake file, and this gives you the instructions on what steps to follow. What steps must the compiler follow, in what procedure, in what way, in what sequence, in order to generate the binaries. So it's important to have that as well. And then it gives you all these other auxiliary products. And that's essentially it. If you go ahead and click modify, it's going to install those various tool chains. I've already got it installed, so I'm not going to go ahead and click modify. So I'm just going to close that. We want to compile from the OpenCV source code, which involves 5 steps. We want to first download the compressed file of the main project as well as the extra modules and extract those files to a folder of our choosing. To do that, you want to go to the GitHub central repository of the OpenCV project, and you want to go for the main module as well as the extra modules folder, which is over there. For each of those, you want to go to code, download zip. I've already done that in my case for this folder. And then for the extra modules, you also want to download the zip over there. So again, download for the OpenCV, the main one, and the OpenCV _contrib for contributions. I've already gone ahead and done that. You can do it on your side as well. Once you've done that, it should appear in your downloads folder, and you want to go ahead and extract the main one, extract all, and the one that contains the additional contributions. You want to extract all to a folder of your choosing. In my case, I've extracted it to a folder called, sorry, just ignore that one while I'm deleting it, to this folder over here. So it's in the same directory. Now what we can do is we're essentially in a position to create a build directory folder, which I'll explain in a short moment what that is. You can call this whatever you want. I'm going to call it my OpenCV. And right now it's an empty directory. And now we're in a position to run the command, the CMake command, to set up that build directory. But by setting up the build directory, what we mean is we're actually going to create the content in that build directory. Now, the CMake command is a build tool that came with the installation process and the configuration process of Visual Studio. Now, it's important that that command is run not in your command prompt, because if you go to the command prompt here and you had to do CMake version, you can see that it's not recognized as a command. So you don't want to do this. You don't go to the command prompt, even if you run as administrator mode. So we're going to close that. What we want to do instead is open Visual Studio, open a local folder. It can be any folder of your choosing. I'm choosing one of these files or folders that we downloaded. Why it doesn't matter is we just want to get into the main window. And what we want to do then is we want to go to Tools, Command Line, Develop a Command Prompt. Now look what happens if we run the CMake version command over here. It picks it up. So what Visual Studio did is the CMake tool, it added it to the path variable. What that means is commands are recognized from when you run them from any directory, from any file. So how do we know what CMake command we need to run in order to build our build directory or to configure the build directory? Well, it's in the README file of the additional project folder. If we scroll down past the introduction, here it even tells you how to build it. It says before we run the CMake command, we need to go to the directory, to our build directory, which we called my OpenCV. So you want to copy this right here, and you want to paste it in here. It's always good practice to put the directories in quotation marks in case there's spaces in the path. Now we've changed directory to the build directory. Now we're in a position to run the CMake command. Now the CMake command has only got two placeholders. Over there, which is the extra modules /modules path, and then the main OpenCV project. So we're going to go ahead and replace that with the actual path. And now what we're going to do is we're going to put in so the first argument is this one here, the extra modules. Again, always good practice put in quotation marks. And then the second placeholder is the other one we downloaded, the main module. Again, putting it in quotation marks. And that's it. If we go ahead and run this command, what CMake is now going to do is it's going to populate and configure that build directory that we made, which is called my OpenCV. So you can see it's busy performing a few actions there and tasks. If you recall, this folder was empty before we ran that command. But if we go into that directory now, you can see it's busy adding content in that. Under the hood, what it's also doing is it's detecting what environment we've got set up. So if we go all the way to the top from when it started, here we can even see the very first line, building for Visual Studio 2022. And if we go down a few lines we have highlighted, it also says selecting Windows SDK version to target Windows for a very specific version. And then it also identified the compiler, which is Microsoft Visual Compiler in its version 19.30, etc. So you can see the benefit of using CMake and why OpenCV uses CMake is it essentially runs a build command that is agnostic to and is not overly concerned about what the environment is. Whether we used another IDE, it would have also worked. Whether we used a different compiler, let's say instead of Microsoft Visual Compiler, we used the GCC compiler, it would have also detected that and configured it accordingly. So CMake is a great build tool, and it builds it independent of what environment you have. Now this will go ahead and last quite a bit until it's completely configured. Now that the CMake command has configured and created the files in the build directory, we can now make changes to the OpenCV project of our own and generate the binaries and headers for inclusion into a project. So we can open the project, my OpenCV, opencv.solution. Now it's going to load that project. And again, CMake, running that command, the output of that is it has configured the build directory to cater for Visual Studio. So it's already created a solution file. Still busy updating. And that's it. Now, if you want to edit the OpenCV source code, you go ahead and you do it. You can go into the respective modules. You can refactor. You can add functionality. You can add your own tests if required. Anything you want. Not going to do it here, but I mean, essentially you can refactor something quickly here, make your changes, and that's it. If you've got source control, update it to source control, and it's your project. And that's what we mean by build directory. It's, although you got the source code from OpenCV, once you created a build directory, it's yours. You can make changes on that build directory. Let's assume we don't make any changes to this. Let's assume we want to go straight to compiling the. We want to compile this into a binary, and we want to use it in our own project. So we're happy with what's been built. In that case, what you do is you want to essentially create the binaries and the headers. So remember, for a C++ project, anytime you want to include a library, a third-party library, into your project, you really need two things. You need the library binaries. That ends in a .lib. Some people call it the libs. That's at least in the Windows environment. For a Linux environment, those are also known as .a files or archive files. So lib files and archive files, they're not compressed. They just think of it as an agglomeration of object files that are put together. So that's the first thing that creating a library does. You get these binary object files, and the implementation is contained inside of those. But you also need the header files. So if we're gonna generate the binaries from this source code, we want the output of both the lib folders and the header files. So to do that, it's quite simple. All you need to do is you go to CMake targets, so you expand that. You right click on install and you say build. Now when you say build, the compiler kicks in. So the compiler is going to take this enormous project, and together with the build instructions that are contained in the CMake file, it's going to go ahead and it's going to build the project, and the output of that is going to be the libs and the header files. And the directory that is contained in, you'll only see after this thing has completed its process. But for now, let's just be cognizant of the fact of what's in this build folder. Do you agree there's nothing in here called install? VS third-party apps bin. Nothing called install. There's a win install, but there's no install folder. So just make a mental screenshot of that, because once we build this, we'll get a new folder inserted into our build directory. So go ahead and build. And the build has started. Also note that we have selected, as part of the build process, debug and the x64 system type, or the 64-bit version of the binary. If you want to make a 32-bit version of the binary, you will have to repeat this process. If you want to make the release version of it, you would have to repeat this process. So essentially, you can have 4 different binary output types: debug 32-bit, debug 64-bit, release 32-bit, release 64-bit. And you're going to have to repeat this process. So it takes quite a while. Here we haven't even reached 25%, and that's just for debug 64-bit. So go ahead and let this run. As an outcome of generating the library files and the headers as part of the installation process, if we go back to the directory, so remember when we asked you to make a mental note of what's in this directory. It basically had everything included here, except it did not have this install folder. Now that the compiler is done generating the binaries, we can see that the install folder has been included in here. And this ultimately is the output of compiling your OpenCV source code into binaries and headers. It's all included in here. So let's investigate it further. If you go into the install directory, your headers, let's start with those. They are in this folder called include. See, they're all here, .hpp. All your headers are there. All header files. So if your project, which is the next section, wants to use the binaries generated, the headers location is this path over here. Including headers is one thing. Where's the actual implementation? The implementation is contained in the x64 folder. Let's go in there. VC17. That's got to do with Visual Studio, by the way. You see this folder here? Lib. There it is. There's your .lib files. What happens if instead of saying x64, instead of a 64-bit, we did a 32-bit? Well, in the general sense, this doesn't really apply for OpenCV specifically, but for all projects, the best practice is that the build script will create another folder here called, x86, which is the 32-bit version, and all your implementations will go in there. So there'll be a replication of this one. So essentially, if you had to change x64, if you had to change that to 32-bit, it'll go in a separate folder. So that's just for contextual purposes. We're not going to do that now. The other question is what would happen if instead of the debug version we did release and we went through the same process? What would happen then? Well, all that'll happen there is it'll still be in the 64-bit version. It'll still be in there. It'll still be in the lib folder. And all the files will be named the same, except this D here wouldn't be there. So if we did the same process, but instead of debug, we did release, it would be called like that. It wouldn't end in a D. These all end in a D because we selected debug. Whether you choose debug or release, 64-bit or 32-bit versions, the headers will remain the same. So that won't change. We're going to go ahead and write a minimal project that will use the compiled OpenCV library. And to get it to work, we're going to have to specify the relevant include and library directories, as well as the exact dependencies. So what you want to do here is you want to go ahead and open Visual Studio. You want to create a new project, an empty C++ project. And we're just going to go ahead and give it a very generic name here, my project. Okay, now what should we write to test the built OpenCV library? Well, one good idea is to go to docs.opencv.org. Make sure you're on the correct version, which in our case we built using 4.6.0. So we're going to go to the 4.6.0 documents. Better safe to keep apples to apples and pairs to pairs with regards to version numbers. If you've got examples, here's a list of examples we can use to test the OpenCV library. Let's go ahead and select the first one, which is an example using the fast line detector. Now that's interesting because the fast line detector is part of the extra modules. It's not part of the core modules. What this means is if you were to try this code as part of the binary release, it wouldn't work because remember the binary releases don't include the extra module functionality. So you have to compile it from source to get this to work. And not only that, you want to compile the extra modules from source. You don't want to just compile the main module. So we're going to go ahead and copy this because fortunately we did do exactly that process. So we're going to copy that. So it'll definitely work for us. In source files, you want to add a new item, and we're just going to add one main file. And we are going to paste the code here. What you'll immediately notice is the IDE has picked up some linking problems, as we can see by the red lines. But those should go away as soon as we include the relevant directories of the built library. So to do that, you need to go to Project, My Project Properties, then under Configuration Properties, go to VC++ Directories, and you can change your include directories. So the include directories is basically saying, Mr. Compiler, you need to look at this directory to find the header files. And where are those header files? Well, remember, when we created the build directory for the OpenCV project and we built the install folder, it all went under install and the headers went under include. And that's it. If you double click this, it'll show you all the headers. But this is the path we need for the include directories. So paste that in there. Then we need the library directories. This is similar. This is saying, hey, Mr. Compiler, this is the directory you need to look at in order to find the libs. So again, you go to your build directory, also under install. And because we built it for the 64-bit version, when we're building that library, we go to x64. This is just a Visual Studio identifier. And libs. There it is. And again, because we built the library using debug mode, there's a D appended to each of the libraries. So we want this path. Go ahead and copy that. Paste it in there. Lastly, we want to go to linker. And on the input, we want to specify the additional dependencies. So what is this? This is saying, Mr. Compiler, for the binaries, for the libs, we gave you the directory, but that directory is going to give you every single module that OpenCV has. We might not want every single module. To make a piece of code work, you might only need this one, that one, and that one. And for another project, you might only need that one, that one, that one. What that essentially does is it keeps your output files size to a minimum. It prevents binary bloat. You don't want to include binaries as part of your project that are not required. But you can. It can still work if you do. And in this day and age, size is not a premium, so we can go ahead and include as many as we, pretty much all the libs, and it'll work. But what you can do here is include only the ones that are required for the extra modules and all the ones for the core modules. So let's just break this down. Which ones of this file have I included in the additional dependencies? For the extra modules, I only included the XIMG processing 460D. By the way, 460 in all of these, that's just the version because we're dealing with 4.6.0. That's the version we built the libraries in. So for the extra modules, we only need that one. And we know that because here it's in the header. Then, to be safe, we can just go ahead and include all of the main modules. We don't have to selectively include a subset of it, as some of these refer to here. We can include all of it. And again, space is not a premium, so we can go ahead and do that. So how do we know the main modules? Well, it's simple. It was in the main page of the documentation, main modules. So core, image processing, image codecs, video, high GUI, video, features, object detection, etc., etc. Now there's a one-for-one naming convention with this documentation here to the libs that are specified in here. So I took all of those main modules and I included them in here. Core, image processing, image codings, video, input, output. So literally one-to-one to all of these. But of course you have to add in a .lib as it's named over here. So these ones are all the libs from the core module, and this is the specific one we'll use for this example for the extra modules. So I'll just scroll down so you can see it. See, not that many. Click OK. Click Apply. Click OK. As you can see, the red lines are gone. Now for this project to work, it's going to need a picture as an input, which is a picture, photograph rather, of a corridor. You can use any other picture you want. Just find an image of a corridor. I'm going to cut that and paste that where my main CPP is. Because when you run the program, this code says look in the root directory and use that image to detect the lines. And now we're ready to run the program. So we're getting an error saying the code execution cannot proceed because a certain DLL was not found. So this error is happening because the execution program, which is my project.exe, it did not find all the DLLs that are associated to the libs. So under the settings that we're going to go into now, it expected the DLLs for those lib files, but while it's searching for it during program execution, it couldn't find it in the current root folder of the project, nor could it find it in the path folders. So remember, DLLs are dynamic linked libraries. They are resolved during runtime. What we therefore need to do is to tell the program where to find those DLLs. We've got them. We just need to tell the program where to find them. So again, there's two options. We can take those DLLs as the output of the library and put it in the root folder of the project, or we can add the path to those DLLs. We're going to add it to the path in our case. So this is going to make sense once I actually open the settings to do so. So what you want to do there is you can type in environment and go to edit the system environment variables. This is essentially under the control panel. So I've gone ahead and already done this step. So when you open the system properties, you want to go to advanced. You then want to go to environment variables. You then want to go to the path under system variables, and you want to click edit. So again, I'm doing this all in one go so you can see how it goes from step to step. You want to change the environment. So again, search bar, edit the system environment variables. It's going to open up this. Then you go to environment variables. It's going to open up this second pane. Then you go under system variables, and under path over there, you click edit. That is going to bring up this third window or pane. Over here, you want to specify where those DLLs are found. And by doing that, this project, my project, basically during runtime, it'll know where to find those DLLs, and it'll know that because you're specifying the path here. So here you want to add a new, and you can put the path to those DLLs. Now, where are those? Well, when we built the library, remember we had the install directory, our headers were in the include, and under x64 vc17 under lives, here are our lives. Our DLLs are very close to where these are. If you go one directory structure up, there it is, bin binaries.dll. So these are your dynamic link libraries. So what you want to do is you want to copy this path and you want to add it over here. Now, when you add those, some people say you've got to restart the computer. It's not strictly necessary. All you need to do is basically close Visual Studio and open it again. So we're going to go to My Project, and we're just going to double click the My Project solution. It's just still busy thinking. And again, you want to make sure, because we built the library under debug 64-bit mode, we have to do apples with apples and pairs to pairs. We have to select debug and 64-bit. If you built the library using release, you would have to run this under release 64-bit version. Let's go ahead and see if this works. And there you go. You've managed to use the OpenCV library by building it through source.